In this problem, we need to find the 40th percentile of the diameters of ball bearings. And we're given their mean and standard deviation, and we're told that they are normally distributed. So, how do I get started with this? Well, what I'm going to do is I'm going to draw the normal distribution. And what we need to know is what is the diameter of a ball bearing that falls above 40% of the other ball bearings. So the 40% is the bottom 40%. So I'm going to find a little separation here, and the idea is that 40%, okay, that's a little better, 40% of the ball bearings are going to fall below the value that we're looking for. So what I'm looking for is a data type value, right? Because our data values are the ones that would fall all along the axis here. And then that's opposed to the percentage, which is the area that's filled in a certain region of the graph. So when we're starting with the percentage and we need to find the data value, what we're going to use is the inverse norm function. So in the calculator, I'm going to type in inverse norm, and I'm going to explain how to get there in just a second. So inverse norm, and then I put in the percent that falls on the left. And that's really important, that it has to be the percentage on the left. So not every question is going to ask you, they're not going to necessarily give you the percentage on the left, and you may have to figure that out. So we've got 40%, comma, and then I put in the mean, 25.1, comma, and then the standard deviation, which is 0.04, and close my parentheses. Now, how do I get this to come up on the calculator? All right, to get inverse norm, I press the second button, and then vars, and then the number 3. So vars is right above the tan button. So it's the tangent button. So it says tan on it. And, it's to the left of the clear button. So that's how you can find that. All right, so you've got inverse norm, and then the comma. The comma is above the 7 button. So that's what you need to enter that. And when I enter that, then what do I get as a value? And I get 25.0899. So what that shows me is that on my distribution, the value right here is 25.0899. So any value on the left of that would be in that bottom 40%, and of course any value above 25.0899 would fall in the top 60% of diameters for ball bearings. Let's take a look at part 2 of this question. So now I want the 32nd percentile of the diameters. So again, I'll use that inverse norm function. But now it's the bottom 32%, so I just make the percentage 0.32, comma, and then the mean and the standard deviation. And this gives me 25.0813. So that's how you do that one. It's really just the same problem, only 32% instead of 40%. So let's take a look at part 3. This problem is a little bit different. Here it says a hole is to be designed so that 3% of the ball bearings will fit through it. The bearings that fit through the hole will be melted down and remade. What should the diameter of the hole be? So we want the lowest 3%. So again, that's going to be 3% on the left-hand side. So this is similar to the percentile type, and I'm going to use the inverse norm function again. So we have inverse norm of 0.03, comma, 25.1, comma, 0.04, and then that equals 25.0248. Okay, so that's how we get that one. And now let's take a look at part 4, which is a little different from the first 3 parts. Now here we want to find between what 2 values are the middle 90% of the diameters. So in order to do this, I'm again going to look at my normal distribution. In this problem, they asked us to find the values that are the boundaries for the middle 90% of values. So the middle 90%, what we're going to end up with is if we have 90% in the center, that means that each of these tails is going to have 5%. Since we have the middle 90%, of course, 100% minus 90% gives us 10%. Right? So there's 10% left over, but there's 2 tails. So since we have to be in the middle of that, then we take the 10% and divide it by 2, and that gives us the 5% in each tail. All right, so now what I'm going to do is I'm going to find the value that falls above the bottom 5%, and then the value that falls below the top 5%. But remember what I said, which was the calculator only works from the left-hand side, what percentage is on the left. So, let's see, make some space here. So when I look at this, what I'm going to ask is for this value, what percentage is on the left? So for this one, that would be this percentage right here, which is 5%. But now I need to ask that same question on the right-hand side. What percentage is on the left? So now the percentage on the left is not just the bottom 5% here, but also all of this as well. So 5% plus another 90%. And so that gives me 95%. So again, I'm finding 2 different values, so I'm going to have 2 different things to type into the calculator. Okay, so when we have 5% on the left, then my value is 25.0342. Okay. Right? Yes, okay. And when I have 95% on the left, or 5% on the right is the same thing, then I have 25.1658. Okay. So those are our values. Now, I'm going to go back to the first screen and let's take a look at where all these values fall relative to each other. Okay, so here we can see kind of a summary of all the results of this problem. So the first one, we had the bottom 40%, or I should say the 40th percentile turned out to be 25.0899. We have 40% of values fall below that value. Then 32nd percentile is 25.0813. So 32% of values fall in this area below. And then we wanted the bottom 3%, right? Because those were the ones that were too small. So they were the ones who fell through the hole. They were too small. And so 25.0248 for that. And then we wanted to know the middle 90%. So that's here, right? This is the middle 90%. So right across there, okay. And so that is bounded by 25.0342 and 25.1658. And that's because 5% fall to the left of the first one and 95% fall to the left of the second one. So that's how you do that problem.